Welcome to Mr. Chalk's Revision Tips. In this video we will look at types of energy, energy transfer. First type of energy, magnetic energy. So this is energy stored when repelling poles have been pushed together as in a magnet and pushed apart. Heat energy. So heat energy is talking about the kinetic energy that particles have when they're moving in an object. In most cases this is just vibration. The vibrating molecules cause things to heat up. The faster they vibrate, the hotter it becomes. You have chemical energy. So this is energy stored in chemical bonds such as those between molecules. Kinetic energy. So kinetic energy is talking about the energy of moving objects. So if we look at this question, so the mass of a cyclist is 80 kilograms. The speed of the cyclist is 12 meters per second. Calculate the kinetic energy. So the equation is there. You'd work it out by 0.5 times by the mass, which is 80, times that by the velocity squared, which will be 12 squared, which would give you a kinetic energy of 5,760 joules. So the second part, so when the cyclist uses the brakes, the bicycle slows down. This causes the temperature of the brakes to increase by 50 degrees. The mass of the brake pads is 0.04 kilograms. Its specific heat capacity is 480 kilojoules per centigrade. Calculate the change in thermal energy. So the equation to use is shown below. Have a go at using the equation, then check the answer. So that would just be 0.04 times 480 times by 50, which would give you an energy change of 960 joules. Another type of energy is elastic energy. So elastic energy is a potential energy that is stored when things are either squashed or stretched. You have electrostatic energy. So this is energy stored when repelling charges have been moved closer together or when attracting charges have been pulled further apart. Gravitational potential energy. So this is where things are gaining more energy the further up or the higher they come from the ground. So at ground level, when something is just sat at the ground, it will have zero gravitational potential energy, and the further it's lifted up, the higher it will get. And nuclear energy is created by the release of energy from nuclear reactions. These reactions usually use uranium or plutonium. A relatively small amount of fuel is required to produce a huge amount of energy. So if we look at this question, so the diagram shows a tennis ball that is thrown vertically through the air. At position C, the tennis ball has just left the player's hand at a speed of 5 meters per second. The tennis ball has a mass of 0.058 kilograms. Calculate the kinetic energy. So the equation is above. Have a go and then check the answer. So you're going to have 0.5 times 0.058 times by 5 squared, which will give you a kinetic energy of 0.725. So next, so at position B, the tennis ball has 0.38 joules of gravitational potential energy. Calculate the height of the tennis ball. So the equation that you'd need to use would be mass times gravitational field strength times by height. So you would work that out by 0.38, which would give you a height of 0.67 meters. Energy can remain in the same form for millions of years, or sometimes just a fraction of a second. Right, energy cannot be destroyed. It can only change from one type to another. So here are a few examples. So we've got mechanical work. So a force is now moving an object through a distance. Electrical work. So charges are moving due to potential difference. We've got heating due to temperature difference caused by electricity or some sort of chemical reaction. Radiation. So energy is transferred as a wave. So light or infrared light, radiation, such as those emitted by the sun. A Sankey diagram can be used to represent these energy changes. So your arrow that goes along the top always shows the useful energy. Any arrows going down show how energy is being wasted. Thanks for watching.